Good afternoon, ladies and gentlemen. It's really our ultimate pleasure to welcome you to our ASHRAE Falcon Chapter webinar. In this regard, we will just share with you the ASHRAE Code of Ethics. In this and all other ASHRAE meetings, we will act with honesty, fairness, courtesy, competence, inclusiveness, and respect for others, which exemplify our values of excellence, commitment, integrity, collaboration, volunteerism, and diversity, and shall avoid all real and perceived conflicts of interest. It's really our pleasure to have guest of honor, Mr. Hassan Younes, today, talking about very important subjects and essential topic like energy management and the energy audits. Hassan joins ASHRAE Falcon initiative of exchanging technical knowledge with the chapter members, aiming to increase the awareness. Hassan is the co-founder and the director of Greven Consultant, specialized in sustainable design, building energy efficiency, policy making, and district cooling. He is also and currently the ASHRAE Falcon Chapter President. He is also the ASHRAE trainer at the ASHRAE Global Center. And I hereby welcome Hassan on board. Hassan, the mic is yours to start your presentation.
Thank you, Abdullah. Hello, everyone. Ramadan Kareem. At the Falcon Chapter, we decided to start a series of webinars. First one was last week. We're going to have some more. I think Abdullah, at the end of this presentation, will also highlight some of the upcoming webinars. So my name is Hassan Younes. Welcome, everyone. I know a lot of people are joining from different places. It's difficult times. Hope everyone is keeping safe. I know we don't have a lot of time. A lot of people are fasting. So let's get into the subject. So today we're going to talk about the energy management and energy audits, mainly focusing on the investment grade audits and what are the requirements of an IGA. Contents would be definition and levels of energy audits. What is an investment grade audit? The IGA process, what to expect during a facility visit, and before the facility visit, what needs to be done, and then what is the timeline for an IGA. Now, also, I want to tell you that we have the handouts available, so you can download the presentation. We're going to have some questions, some polls that you'll answer. 4 polls will be shown on the screen. Just some questions about the topic, so that the topic is not too boring. What is an energy audit? An energy audit is the first step in identifying measures to reduce energy consumption and develop a retrofit plan. An IGA makes that plan feasible. Energy audit, what is the definition of an energy audit? Is done to determine where, when, why, and how energy is used in a facility, and to identify opportunities to improve efficiency. The main outcome of an energy audit is a list of recommended energy efficiency measures or energy conservation measures. EEMs is what ASHRAE likes to call it. ECMs, I think mainly AEE, Association of Energy Engineers. Sometimes you would hear energy saving measures. They're all the same. And there are stated energy saving potential and an assessment of whether EEM installation costs are a good financial investment. Energy auditing services are offered by energy service companies, energy consultants, and engineering firms. As you can see, as per ASHRAE, and recently, not very recently, 2018, there's the ASHRAE Standard 211 has been published. Before that, we used to look at a publication called Procedures for Commercial Building Energy Audits from ASHRAE to define what are the levels and what needs to be done in each level. So we have kind of 4 levels, let's say: a preliminary energy assessment, what we call a PEA. That's a rough calculation. We're going to talk about that. Then we have the level 1, the level 2, and the level 3. What's the scope of energy audits? Energy audits can be done in different levels of detail and complexity as defined by ASHRAE Standard 211. The higher the level, the more accurate the analysis is, the more time is required, and the more costly the IGA or the audit becomes. So there's the preliminary energy use analysis. That's mainly to calculate your EUI, or what we call the energy use intensity, or Energy Utilization Index. We call it EUIs. That's basically looking at the whole energy consumption for a year, let's say, dividing that by the square meter, normally is the air-conditioned area or the GFA, and that would be the EUI. So we're normalizing the energy consumption. Then you would compare it to similar buildings. So let's say I am doing an energy audit in Dubai. It's an office building. I would take the readings for 1 year for the energy consumption. Let's say the building is only using electricity, so that would be the electricity bills from DIWA. I would divide that by the area of the building, the GFA, and that will give me the EUI. Now, I would not need to compare that to see how is my building doing compared to peers. So if, let's say, I have some data from either audits that I've done before, if there's something publicly available. In the US, you have the CBECS, which is a study done by DOE. That would give different EUIs for different climates, different areas, different cities, and then you can compare your building to others. If you see that your building is really doing well, no need to go with any further measures, right? Because you know that your building is doing well from an energy point of view. If the building is showing very high consumption compared to others, it's worth looking further. So you could either go with a level 1 audit, level 2, or level 3. Level 1 audit will give you very rough costs and savings for ECMs. It will just compare your EUI to a target EUI. So you'd look at your building, let's say it's using 300 kilowatt hour per square meter per year, and the average in the city is around 200. So the potential of saving is 100 kilowatt hour per square meter per year. Multiply that by the area, multiply that by the tariff, electricity tariff, or whatever energy tariff you have, and that will give you the amount of potential savings that you have. In the level 1 audit, also, you would look into ideas, basically. So I would say I will change the lighting from normal lighting to LED, and that will save me a good amount of money or a good amount of energy. I would not mention exactly what it is. There are no numbers. And I would say if it's a high cost or a low cost or a no cost. So these are the requirements for a level 1 audit. Level 2 is more detailed. I need to have end-use breakdown. We're going to talk about that later. Detailed analysis. I need to have measurements on site, and I need to have very detailed cost and savings for every energy conservation measure or energy efficiency measure. Also, I would look into O&M charges. What are the different changes in operation and maintenance that is required if I do any changes? Now, the level 3 is basically a level 2 plus plus. You need to do more measurements, more analysis, more time spent on site, and probably you would want to do some energy simulation. So it's not required, but it's normally preferred to have an energy model along with extensive measurements. So what are the energy audit required tasks? If you look at the level 1, you conduct the PEA, which is basically getting the kilowatt hours per square meter per year. It would seem a very simple thing, but if it's a really big building, let's say you're doing a PEA for Dubai Mall, probably there's many different meters for electricity that you need to collect. That building is also served by district cooling, so you need to collect district cooling as well. They probably have some LPG for the kitchens and for the F&B. So you need to collect all the energy consumption and then come up with the EUI, then compare it to other similar buildings. Conducting the walkthrough survey. Walkthrough survey is basically going to the building, asking questions for the O&M personnel, checking how things are being done. If there's a BMS, you'd look into that. Normally, no measurements are required within level 1. Then you would identify the low cost and no cost measures, and then identify capital improvements, let's say like change of chillers, change of pumps, anything that really requires a lot of money to change. Now with the level 2, you do exactly what you've done for the level 1, plus you need to review the mechanical, electrical design, condition, and O&M practice, so you do more detailed analysis. You would need to do measurements. So you need to do measurements on, let's say, electrical power consumption for the chiller, how much, what is the kilowatt per ton for the chiller. You look at the fans, what is the watt per liter per second, what is the amount of fresh air flow going or outside air flow going into the building, what is the amount of exhaust flow. The more measurements you make, the more accurate your assumptions would be. And for the longer period you have it, especially for variable loads, the better the quality of the energy audit. You need to do analysis for the capital measures. We're going to see later what ASHRAE 211 tells you about what are the savings, how you're going to calculate the costs, basically the capital costs, what it should include, what it should not include. You should meet with the owner and the operator to review the recommendations. Sometimes you might come up with a recommendation that makes great sense to you, but it might not be a good option for the building for various reasons. So you need to speak to the owner, tell them what are the energy conservation measures that you have, and then decide on the final list of EEMs or ECMs. Level 3, you'd need to conduct additional testing and monitoring, staying more on site, doing more measurements for a longer period of time. The longer the period, the more accurate the results would be. A detailed system modeling, normally people use an energy model as you would do the energy model. We're going to talk about that later as well. And you need to provide schematic layouts for the recommendation. So it's not just an idea saying, you know, change this into that or change this pump. You need to show some kind of schematic on how this should be done with a little bit of specifications as well. Energy audit required outcomes. Each level has an outcome. So for a level 1, you need to estimate savings from utility rate charge. If that's the case, and here, let's say in Dubai, that would not be applicable. Compare EUI to EUIs of similar sites. Definitely you have to do that. Summarize the utility data, maybe on Excel sheet, spreadsheet, put it in a report. And estimate savings if EUIs were to meet targets. So level 1 is very, very brief. You would just put ideas of things that needs to be changed. Normally, it's just you're just testing the water to see if there is a potential or not. Most people go with a level 2 audit because it's more robust. For level 2 audit, you need to estimate the low cost, no cost savings. So let's say if you go and find that the pressure hand unit or the outdoor air hand unit is working 24/7, it's an office building, you don't need to run it 24/7. Maybe during this pandemic, it would be a good idea maybe to keep the ventilation, but during normal times, you should be turning off the system when there's no one in the building. So when there's no occupants, you turn off the systems. That is the low cost or basically a no cost measure. So you can go to the BMS and change the schedule of that particular equipment, and that will save you a lot of energy. You need to calculate detailed end use breakdown. We're going to see that later, how it looks like. Estimate capital project costs and savings. How much it's going to cost you, let's say, to change the chiller. What are the savings? What is the O&M? So O&M could increase, could decrease. If you're buying a new chiller and replacing a really old, let's say, air-cooled chiller, probably the maintenance will go down. But if, let's say, you're adding an absorption chiller, maintenance will go up because you need expertise for that. You need to have a complete building description, equipment inventory. You need to show every piece of equipment that uses energy in the building. Also, you need to show the recommended measurement and verification. Normally, we follow either ASHRAE Guideline 14 or the IPMVP. And you need to perform financial analysis of recommended ECMs. Level 3, write detailed description of recommended measures, do some schematics, some specifications, and compile detailed ECM cost estimates, more even detailed than the level 2. So what are the benefits of the investment grade audit? Now, investment grade audit, you will not find that term in ASHRAE 211, but this is what normally ESCOs, energy service companies would use, meaning that they're willing to invest, or the client is willing to invest, and for them to come up with this decision, to take the decision that yes, it's worth it, they need to see something of high quality, high accuracy, so that whoever is financing the project is at ease that this thing will work and he will get his money back. So you need to have something very detailed. A level 1 audit, you show me a level 1 audit, and you tell me there's a great potential, I will not put money on it because it's not very accurate. I want to do measurements, do proper modeling, do a lot of extensive studies, and then show me a report that exactly tells me how much I'm going to put as money and how much I'm going to save, and what are the risks on every energy conservation measure. So the IGA would list all possible ECMs. It would have a detailed energy breakdown of every piece of equipment. It will have extensive on-site measurements. So this end-use analysis is backed up with a lot of measurements on site. You would probably need also a calibrated building energy model. ECM's feasibility, you need to have a technical economic matrix. Also, you need to check with maybe more than one supplier to see like you didn't go with only one supplier, so to have at least more than one quotation. And you would need to do some engineering analysis, preferably at least a schematic level, to show how things will be installed. Now, there are some IGA that needs to be considered, other stuff like human factors, the skills of O&M staff. If you need, let's say, you're adding an absorption chiller, you probably would need additional staff members that have the required expertise to run the system. You might also need to train the existing O&M staff on new equipment or new sequence of operations that will be implemented. Budgetary funds, you need to look at that. Facility and equipment conditions, and additional factors that might affect the project ROI. Now, what is the energy use baseline and the energy end use? Baseline is basically the initial value for energy consumption, which is used to compare before and after energy consumption to determine savings. The baseline is normally at least 12 consecutive months. So if I'm looking, let's say I told you now, go do an energy audit, right? And I want to select the baseline. If I was in 2021, I would say yes, the baseline should be 2020. However, if I know that 2020 was not a normal year because we had a pandemic and that building is a hotel, let's say, we know that occupancy was very low for a long period of time. So probably 2020 will not be a best case to use it for a baseline. So I would maybe look at 2019 because that was when things were normal and consumption was actually not exceptional. It was running as per normal, the normal situation. So 2019 probably would be a good baseline year. So I would collect all the data from all the meters. What is the energy consumption? And that would be the total energy consumption. Normally, I would put it on a month-to-month on a spreadsheet. Maybe I can also correlate it to the cooling degree days or average temperature to see if my consumption is weather dependent or not. If I'm working in, let's say, this audit is for a industrial facility, I'm producing, let's say, something, then I would want to look at the energy consumption per production and also per weather to see which one is the variable that that the consumption depends on. So it could be an equation that covers both. Now, what is the energy end use? The energy end use is the separation of utility data into general categories based on building energy using equipment. It's done to identify categories that will result in the greatest energy use and cost reductions. This analysis requires utility data, measurements on site, BMS historical data, if you're lucky enough to find that working, and they have been, trending has been used on the BMS, and information on building equipment, consumptions, and operating hours. So you would rely a lot on what the facility management people will be telling you. So as you know, energy is equal to kilowatt times hours. So let's say I go into the building and one of my auditors say, well, I found a really big pump, a fire pump that is 200 kilowatts. Is it worth looking at that? We know that the pump will not run, only maybe for tests every now and then. So it's not really worth it to look into that. And it's not, doesn't constitute a percentage or a big percentage, or even a small percentage of the total energy used in the building. So I would really not look into that. I would look into other stuff, mainly HVAC. If you look at the example here, you can see that for this particular building, chilled water pumps is around 17%, common area fan units 14%, AHU 7%, FAHU 26%. Now I have also some questions for you, like I mentioned. So I'm gonna run a poll here. If you look at the end user analysis of this building, try to come up with the answer. So just give me 1 second to run the first poll. So I'm going to ask you a question. You should see the question on the screen in 1 second. And choose the answer. So basically the question is, this building is cooled via what? Is it air-cooled chillers? Is it not cooled at all? Could be like a warehouse. Water-cooled chillers or district cooling? As a hint, look at the end use analysis. Do you see any chillers? I don't see any chillers. So probably chillers won't be a good answer. I'm gonna give you like around 1 minute or 1.5 minutes, let's say. So we got around 42 voted. Let's give it 1 more minute. All right, so I see around 60% got it right, which is all right. I'm gonna close the poll now. Almost 70% voted. So almost 60% voted that it's district cooling, which is the right answer. Why is that? If you look at the end use analysis, you can see that there are no chillers. I can see chill water pumps. So there are some pumps pumping chill water within the building. So it cannot be not cooled because I have fan cores, I have air handling units. It's not going to be air cooled chillers because I don't see any chillers here on the end use analysis. So the only answer could be district cooling. So this is showing here the kilowatt hours or the electrical consumption of the different components of the building. There would be another component, which is the district cooling, which is not shown here, which is normally would be in kilowatt hour or ton hours. So thank you very much for voting. So the correct answer is district cooling, mainly because I don't see any chillers, but I see cooling and chilled water pumps. And you look at this end use analysis, you can see that the you see FAHUs or outside air handling units, fan coil units are the highest consumers. Chilled water pumps also high, and the lighting. So these are the things that you need to look at. I would really not look into the lifts. It's not going to save much. Even if I save 50% of the lift's energy consumption, it's not going to end up with a lot of savings. So I would focus on the lighting, the chilled water pumps, the ventilation as well. So what is the process and methodology of an IGA? First, I would go with a walkthrough audit. So I would walk through the building, ask the facility management, and this I need to be very, very careful here. I will need to be very, I shouldn't show that I'm a threat to the facility management. Why is that? If they don't give you the right answers, you probably will miss on the right calculations and the right assumptions. So you need to be very careful and respectful when you speak to anyone, basically, but especially when you talk to the facility management, because sometimes they feel that you are a threat. You are coming there to audit them. The name is a bit scary. That's why ASHRAE wanted to change the name to energy assessment. So you need to be very careful when you speak to the facility management and explain to them that coming here to help them to operate the building in a better way. Data collection, drawings, submittals, cut sheets, O&M manuals, utility data, trending from the BMS. You need to do a data records update check. Normally, we would do a checklist, send it to the client, and then get the information, and then there will be a live document to show what has been submitted yet and what is not submitted, what is available and what is not available. Then you do the utility bill assessment to see how much is the building using in terms of consumption, the EUI, see if it's weather dependent or not. Do the energy baseline check. Normally, we would ask for 2 years of data in terms of utility, and then we come up with the energy baseline. End use analysis, identification of potential ECMs. Definitely there you would be doing a lot of measurements as well on site. Come up with energy end use analysis, identification of potential ECMs. Energy simulation could start even before that, depending on how and why you're using the energy simulation software. Then you go into the technical and financial analysis of the ECMs. You meet with the client, you prioritize which ECMs to go for, then you go with further engineering and detailing, doing some drawings, some specifications. Everything should be in an audit report, basically. Then if it's an ESCO project, you'd go with an M&V plan. So what is the measurement and verification plan? How are we going to verify the savings? So we're gonna say, I'm gonna save this much by changing the chiller. How do I measure and verify that these savings have occurred? So there would be an M&V plan. We're not gonna talk about that. Maybe we can have another webinar on that. And then you go with the final implementation plan to show when everything will happen on site, off-site as well, and that will be submitted to the client for their approval. What kind of data that needs to be captured in IGA? I mean, that's not comprehensive, but I tried to put some of the data that normally is required. Operation characteristics, what to measure, points like space temperature, humidity, space lighting levels. Again, you need to make sure that whatever ECMs or EEMs we're proposing, we're not affecting the standards of comfort, we're not affecting the indoor environmental quality, that is temperature, humidity, indoor air quality, light, visual light, and sound. So you need not affect negatively any of these aspects. You should improve them basically, or keep them the same. Normally, you should aim to improve them. So you need to take the space temperature and humidity to make sure that there is proper thermal comfort. Sometimes you go into buildings, you find that the fresh air handling units are turned off completely. Now, if you go to the client and tell them, see, we did the measurements and we found out that the FAHU is either turned down to a very low speed, so that it's not, let's say, following ASHRAE 62.1, what do you want us to do? We can reconstruct the baseline to assume that this FAHU is working, and then we would update and adjust the baseline to show what would have been the energy consumption, and then start from there. Or if you want us to keep the FAHUs closed. So it's up to the client to decide. Normally, we would advise them that they should, make sure that the equipment is working properly, and especially when it comes to indoor air quality and health and safety. So we need to advise the client that they need to fix these things. Space lighting levels. Sometimes you go into a building, you find it's too bright. You take the measurements, lux levels, might find out it's 1,000 lux level in a corridor. You can easily do delamping in that case, remove some lamps to decrease the lighting levels to what is required. In offices, normally it's around 300 to 500 as per ISNA and SIPSI. You need to take CO2 levels sometimes to see if the building is under or over ventilated. So I would take outdoor airflow rates and CO2 levels and VOC levels if I have the equipment. Chill water temperature, supply and return to see if they have any low delta T issues. Operating conditions like loads, cooling loads. I can put a BTU meter on the chiller to check what is the cooling load. I probably would put it there for a month if I can. What are the peak loads? Electrical load. I can put the power analyzers on the MDBs or the MCCs or any kind of equipment I need to take the measurements of. Lighting power density. Taking what is the watt per square meter in a specific room, I can compare it to 90.1 to see if I am above average or below the standard requirements. Fan and pumping power loads. There are some spot measurements that need to be taken. So if, let's say, I see a pump that is constant speed or a fan that is constant speed, let's say a outdoor air handling unit sitting on the roof, it's constant speed working 24/7. I really don't need to put a meter for more than a short amount of time just to see what is the power consumption. Then I can multiply it by the assumed hours that I know from the facility management or from the BMS trending that this equipment is running 24/7, 8,760 hours a year, basically. Light levels, that's spot as well. Flow and constant speed system, that's spot measurement. Data logging, I would do data logging to check what are the schedules, when do motors turn on and off, or lighting. Equipment performance, if I want to check the kilowatt per ton for a chiller, I need to put a BTU meter to check the cooling load, and I would need to put maybe a power analyzer on the electrical side to see what is the kilowatt per ton. Compare that to the nameplate to see if there's any derating or how the equipment is being used. Normally, I would put that for at least a month to see under different weather conditions what's happening. Energy recovery efficiency, if I have a fresh air handling unit or an outdoor air handling unit, when I have a heat recovery wheel, I can take the temperatures before the wheel and after the wheel on the exhaust side and on the outside air side to see what is the energy recovery efficiency, compare it to the catalog value and see how much it's doing, if it's worth changing it, maybe cleaning it, and see what is the issue with that particular heat recovery wheel and why it's not performing properly. It could be performing properly, and then just assuring us that it's working properly or not. Pumps and fan efficiency, what is the watt per liter per second for the pump or for the fan? Lighting efficacy, what is the watt per lux level? So comparing lighting equipment to, or lighting bulbs to others or fixtures. So for logging, like I mentioned, variable flow systems, I need to do logging. So it should be maybe, let's say, interval of every 15 minutes, maybe I take one measurement. So I would put the logger and we'll set it that every 15 minutes it takes a reading. Could be down to 1 minute if I want something very accurate, depending on what kind of equipment I'm trying to measure. Here are some of the data logging equipment and measurement equipment that I normally personally use on site. You can see the energy analyzer, the power analyzer. That's very accurate to get power consumption. Also, it can give you if any harmonics are on site. It can show you that through power factor as well. Bit expensive but very useful. Airflow meter to check what is the flow on, let's say, an air handling unit. Also, it can show us the differential pressure, let's say, between the indoors and the outdoors. Ultrasonic flow meters coupled with temperature sensors on the supply and return for the chill water on the chiller to show us what is the BTU meter, or on the main header. Infrared contact thermometer, if something is very far, I need to take the temperature, I can use that. If something is very hot, let's say a boiler or a pipe that is exposed, I can use that to check the temperature. I can use a clamp meter to check the volts, current, and instantaneous power. Indoor air quality, CO2, VOC, CO, especially if I'm doing any car park measurements to see if the car park is being well ventilated, and if I can reduce the speed on the fans to gain some efficiency and still making sure that the CO levels are within the requirements. Light meter, thermal imaging camera, I can use that for envelope diagnostics if I want to check if there's proper insulation or not. And it will show me, let's say if I take a photo of a wall, it might show me where there is insulation and when there's not insulation, where there's some heat seeping in or out of the building. I can use it also for equipment diagnostics, so I can look at electrical panels to see if there's any points that have been heating up. I can use occupancy sensors, lights, so I can put that sensor and see if there's any movement or the lights are on or off. Now I have another question for you here. It's a tricky one. So just give me 1 second to open the next poll. All right, launching it now. So the question is, which of the equipment on the slide can measure U values of a wall? So it's a BTU meter, energy analyzer, thermal camera. Again, the U value is basically looking at the wall and seeing, measuring what is the heat transfer, basically per square meter. So let's see. Gonna give that 2 minutes. Around 72% voted, and the right answer is none. Basically, none of those equipment shown here can give us the U value of a wall. What we would need basically is a heat flux meter. So we need to install that for a long time, maybe 1 week, maybe 2 weeks, to check the heat flux within the wall and with the temperatures in and out, and then that would give us the U value of the wall or a roof. Normally we use it for walls or roofs. So none of those. A BTU meter will only help us check, let's say, chilled water systems. The energy analyzer is only for electrical systems. Thermal camera, although thermal camera, that I thought maybe a lot of you will because I kind of tricked you when I mentioned that. We use it to check if there is proper insulation or if there is insulation or not. We don't know the value of the insulation. We just see that part of the wall, it looks a different color than the other part. It means one part is actually having insulation, the other one does not have an insulation. So thank you everyone for voting. We got 76% voting. It's very good. Now, what are the IGA challenges? Risk and mitigation measures, how to make an IGA more accurate, end-use analysis and accuracy, overestimation of saving, that's the risk. Mitigation, doing extensive site measurements, staying on the site for a longer period of time will give us better visibility on what's happening in our building. Missed opportunities, reduce achieved savings than potential, that's the risk. Auditor capability assessment. So before hiring the auditor, make sure that they have the right expertise. We have another slide on how to select auditors. Also, having a third party to review could be an option, especially with ASCO projects. We act a lot of times as sometimes consultants to do that. So that would be a good idea as well to do some peer reviews. Constructability assessment. Sometimes the auditor or the ASCO comes up with an idea that is not buildable. So we need to have proper detailed engineering analysis. That would be the mitigation. Disregard to infrastructure as well. Sometimes the ASCO or the energy auditor would propose something that disregarded the infrastructure. It's not going to work without the proper infrastructure that's not there in the building. So that could be an issue. We faced that one time when they were adding VFDs on some panels and there was not proper grounding because the building was very old, and the VFDs, whenever they turned them on, it would trip. Overestimating savings, risk is actual project feasibility. We've seen that a lot. I've seen it in many peer reviews where people just overestimate savings. Mitigation is to do extensive measurements, do some computer-aided simulations and peer review. Underestimating costs as well, very much seen it in a lot of audits. People assume that the costs are low because they don't do proper condition assessment. So you go to a site, say, okay, I'm going to put VFDs on your primary pumps, and it's a primary only system, an old system, and this will save you a lot of energy. But it's a three-way valve system. You should probably be changing the valves as well, but that was not being considered during the energy audit. And then when they come to site, they find out, no, we need to change the valves now. And the payback period jumped from 2 years to 5 years now, which is not as per the client's requirements. Client maybe asked for 3 years payback maximum. So these things are very important. Proper condition assessment should happen on site. Success factors. How can we ensure IGA success? A client, you should have awareness and buy-in from all the stakeholders, facility management, high management, FM team cooperation, data availability and sharing of that data, transparency in data exchange, facilitation of site and equipment access. That happened to us actually last week or 2 days ago. We went for an audit and nobody was there. So although we told them before that we're going, and they told us yes, come, but nobody was there. So make sure that there's proper access. The auditor, you should appoint an experienced and capable team. Let's say you are doing an audit for a hospital, you probably would want someone with maybe an HFDP, an ASHRAE certification, or someone who has worked on hospitals before. We've worked on hospitals before, and it's not easy at all to do energy audits for hospitals. Commitment to timeline and schedules, use calibrated tools, taking sufficient set measurements, and use of advanced energy modeling software by a certified energy modeler, preferably an ASHRAE BEMP, and also need to be transparent in the cost and savings. Don't just show that, yeah, this energy cost or energy conservation measure is going to cost you $3 million or dirhams, and don't really show why it's going to cost them that much. Now, before the visit, the IGA, let's say, prerequisites. Being prepared for the visits reduces risk of missing data and allows auditors to have multiple sources of data that reduces the uncertainties in results. Site visit access for our auditing team, make sure that that's available. Presence of facility manager and availability of technicians and BMS operators. Sometimes you go to site and you want to go to the roof and tell, well, the guy that has the key is off today. But you tell them, I told you that I'm coming. Well, we didn't know that you're going to go to the roof. So make sure that you state your requirements very, very clearly. BMS operators, what are the login for the system? You need to have that. Systems, ensure that you have unobstructed access to systems. Permission to photograph. Some sites might be very sensitive to taking photographs, so make sure that you can do that. I remember I was working on a project where I had to break the camera on my phone because I needed that to speak to the other team members, and no cameras were allowed on site. Permission to view, analyze BMS, permission to take measurements, and security to safely leave data loggers for interval measurements. Let's say we're going to put some of our data loggers on site. We need to make sure that we're going to put them there. Nobody's going to break them or steal them. So you need to make sure of that too. Safety, ensure we have some auditing safety tips at the end. And also make sure that you are following the client's requirements when it comes to each EHS, especially if you are on sensitive areas like hospitals or oil and gas, where these things are very, very important and have to be abide by them anyway. So you need to abide by the client's health and safety requirements. Another thing on this on the site, make sure that before going to site, your equipment, they are fully charged. If they need any batteries, the batteries are there. Make sure that your camera is there as well. I mean, normally now we're using mobile cameras, but sometimes we used to use the GoPro to go, let's say, and or a camera that can take a video. So when you come back to the office, you would have good visibility, especially for big buildings where you wouldn't remember how did you get there and where is the equipment was located. It would be good to have videos as well. Now, execution and timeline. Normally, an IGA would take between 8 weeks to 12 weeks, maybe more, depending on the scope and how big is the building, how complex is the building. So you need to have project management throughout, quality assurance meetings, progress reporting. Task two is data collection, on-site measurements, FM interviews. Task 3, baseline, data collection and baseline set. Task 4, engineering analysis, so calculations, energy modeling, energy and water conservation measurement identification, doing some schematics as well, financial analysis, selection of the EWCMs, energy and water conservation measures with the clients, and then reports and client presentation. Normally, for a big building, it would take around 3 months. IGA report, this is what is normally required in IGA report. If you go to ASHRAE Senate 211, there's one section, one annex, basically, where it shows what should be in the report. As an example, you shouldn't like really follow it. I mean, you don't have to follow it word by word, but it gives you an example of what needs to be there in an IGA report. Here is also a brief of what needs to be there: bills analysis and baseline, inventory of systems, condition analysis, and measurement details, the end use analysis, all possible ECMs, energy simulation results, implementation process, post-implementation, what requires during the post-implementation phase, and a detailed financial assessment. IGA report, bill analysis and baseline, end use analysis. This is the example that we've seen before. You can see here the consumption per equipment. Now take a minute here. There's another poll. I'm gonna share. So the question is, which systems should be targeted in this particular building? Which systems basically have the highest consumption and you think are good to look at? Remember the 80-20 rules? So the 80-20 rule meaning that maybe 20% of things are causing 80% of the problem. So why don't we focus on that? So I'll just give it 2 minutes. Everybody's getting the right answer. That's good. All right. Almost 75% voted. I'm gonna close this poll. All right, around 80% voted. Closing this poll. So the right answer, like most of you have answered, is the looking at the AC and ventilation fans. If you look at that, it's almost maybe more than 50% of the energy consumption of the building. So that would be a great area to look at. Now, this particular building, this is mainly the common area consumption. So that does not include the apartments. And it's on district cooling. This is why we don't see the chillers like we mentioned before. So yes, looking at the FAHUs, air handling units, common area FCUs, that would be a good thing to look at. Next thing, maybe, so chill water pumps also have higher consumption. So I would look into maybe the outdoor air handling units first, then the chill water pumps, then the lighting, then the maybe common area FCUs. That constitutes maybe more than 80% of the consumption. Looking at, let's say, domestic water pumps, not much. They don't consume a lot of energy. Don't need to waste a lot of time there. So again, what do I expect in an IGA report? From a technical point of view, I need to show the explanation, methodology of the energy conservation measure in terms of how do I get to the savings and how I'm going to implement that on site. What is the technology used? What are the calculations? Practicality, what is the effect on operations? Study of infrastructure. Is it practical to do this ECM or not? I could come up with a energy conservation measure to, I don't know, dig a 3,000 meter well to get hot water and run an absorption chiller. That sounds like a good idea, but it's not, because it's not practical. Economic, cost of implementation, savings, payback. M&V, what is the M&V option? Frequency of M&V activities. Normally M&V, we have 4 options, option A, B, C, and D as per IPMVP. So option A and B are retrofit isolation or isolation of the ECM. So I would look at the, let's say, the chillers only. I would have a boundary around it and look at what's happening there. Option C would look at the whole building, like the whole bills basic, and normally would use the utility bills. Benefit and risk, I would need to show a risk matrix in terms of social, environmental, economic. As well, I need to show if, let's say, the CO2 or the carbon footprint or the ecological footprint of the building would decrease. That is, have a good environmental impact. Also, I need to have a risk analysis for each energy conservation measure or energy saving measures. as well. Now, energy simulation. Do I need to have an energy simulation? I would normally prefer to. So I would build the model on energy modeling software. I would input all the data in terms of the air conditioning system, the way it's being operated, the set points, the lighting, the envelope, anything that uses energy and is able to be modeled by my energy modeling software. I would use it and input that into the modeling software. And then I would calibrate the buildings to the baseline year. So I would input everything I know about the baseline year, how things are being operated, what were the set points, what are the equipment there, and I would simulate the building and get the results and then compare them to the utility bills for that year, for the baseline. And then if I am within 30% per month and 15% per year, that would be enough. Normally it's 15% per month as per ASHRAE guideline 14, and then compare that on also on annual level, should be around 15%. So that will give you a comfort that you have done it properly. And then I would put my energy conservation measures into the software. Let's say I'm changing the chiller. So I had in the baseline model a chiller with an efficiency of, let's say, 1.7 kilowatt per ton, an air-cooled chiller. And I'm putting a new air-cooled chiller, maybe with a 46 degrees C efficiency of 1.4 kilowatt per ton, or 1.3, whatever it is. I put that input and then rerun the model to check what is the effect on energy consumption. If I'm changing the lighting and I have a compound effect here, I'm reducing the energy consumption coming from the electrical part of the lighting system, and I'm also decreasing the loads on the air conditioning equipment. So the energy modeling software will give me that compound effect on both the electrical reduction from the lighting system and the reduction on the air conditioning system. So it's a very powerful tool, energy modeling, to be used to make sure and give you a better accuracy compared to, let's say, just doing an Excel sheet calculation. So you also need to look at the implementation process within the IGA report, installation process for all the energy conservation measures, detailed method statement, especially if it's going for an investment grade audit. You need to show how things are to be done. Shouldn't be very detailed at this point, but in future it should be more detailed. Any disruptions to operations? Do we need to shut down the building or parts of the building? What is the mitigation plan for every risk? And the installation schedule, how much time is going to take per ECM to be completed. Commissioning plan, what are the activities required, process schedules and forms, risk analysis, identification, categorization, and mitigation, and the overall timeline for the implementation of the investment grade audit. Now, post-implementation, the O&M service, what's required? Do you need a different approach to O&M? Normally, we would recommend preventive maintenance. What is the frequency of doing some specific O&M practices or O&M requirements? Operational effects. Do you need to do any, maybe get different personnel or add someone who understands better than you energy conservation measures? Training is very important. What is the objective of the training? What are the related energy service, energy saving measures? Description of the training, who are the participants, duration, frequency, and method. Normally, we would recommend to have video trainings because a different FM company altogether might be the next year, or from the same company, different people might be coming to site. So having that on a video is very important. You can also have added services. You can tell them, well, maybe we'll look at other part of the building to help you operate it as an ESCO or as a auditor. Detailed financial assessment, cost estimates. What needs to be there as cost estimates for the capital cost? This is mainly coming from the ASHRAE 211. So the material costs, labor cost, the design fees, construction management, site-specific installation factors. Let's say you're working on a building that has restricted access for only a few hours a day, and then your cost would go higher. permits, temporary services, tab, testing, adjusting, and balancing, utility service upgrades, commissioning, taxes, profit. All these things need to be shown separately, which is rarely shown in the energy audits that I've seen here. But this is the 211 requirement. You need to show a breakdown of costs. Now, for the life cycle cost, looking at the capital and the operating costs, you need to show the initial costs that I've discussed on the left side. What are the financing costs? Who's going to finance it? What is the interest rate? Annual energy costs, escalation rates, discount rates, tax credits. If sometimes you get a reduction on the taxes if you're doing an energy efficiency project, especially in Europe and the US. Cash incentives as well, rebates. You might get some money and funding from the government or utility because you are reducing your energy consumption. Expected periodic replacements for the systems, especially if, let's say, you're doing a financial model for over, let's say, 30 years, and you know after 10 years you might need to change the DX equipment, so you need to put that also in the life cycle costing. Estimating recurring non-energy costs like maintenance of each set of measures. Such costs will include annual maintenance, service labor costs, replacement of worn parts, or annual manufacturer fees, warranty fees from manufacturers. All these things need to be taken into account. So anything that will cost any penny will be included in the life cycle cost. This is also from ASHRAE 211.
Engineer Hassan, I would like to remind you with the timing, because we have a lot of questions also from the audience.
We're almost done. That's almost the last last slide, basically 2 more slides. So how to hire an energy auditor? This is basically coming from the ASHRAE procedures for commercial building energy audits. First, determine what is the type of audit that you want to go for, level 1, 2, or 3. Determine what the auditor will be doing in future. Will they be also the contractor? Will they also help in the procurement process? Will they help in the developing performance specifications? Will they oversee the contractor work on site? You can have either sole source or you can have competitive biddings. Both have their pros and cons. Look for the following in a good auditing firm. Check for their previous references. Check for work samples. Ask them for energy audit reports. Call their clients and see if they did a good job or not. Check the resumes of the key staff members that will be working on that particular project. The auditor staff preferably should have certifications like the ASHRAE BEAP or the AECEM, and consider whether you need a general or specialized auditing experience. So if you're looking, let's say, to work on a let's say a hospital, maybe someone that has that experience would be better. Maybe you're looking at a targeted audit on chillers. Maybe someone that has great experience in chillers should be used. And also need to make sure that the auditor is vendor neutral and is not just trying to sell you stuff. That is coming from the ASHRAE procedures for commercial building energy audits publication. Now I have another poll very quickly. Basically asking here, what is the cost? This is typically a question here in the UAE. The cost of an IGA, what is the cost per square meter? Is it 1 to 2 dirhams, 2 to 2.5, or 4 to 10, or 40 dirham per square meter? I'm going to open that only for 1 minute. All right. So yeah, the majority got it right, or this is what I think normally, and what I've seen. A proper investment grade audit will cost you around 4 to 10 dirham per square meter. Now in the US, probably it will be around maybe $4 to $10 per square meter. There is a good publication from the DOE, Department of Energy in the US, that has shown normally what is the cost, and it would depend on the complexity of the project, not just the size. So there are two things: the breadth of the audit and the complexity of the building. This is the last slide. Basically, safety first. Make sure when you go to site that you have your PPE, you follow the safety requirements. You can read that later if you want. It's there in the handout just for the because time is limited, and so we can take some questions. And thank you very much for watching and attending this webinar. I think now we can take some questions.
Thank you, Engineer Hassan, so much for the detailed discussion on the different types of energy audits and the deep details of the energy of the IGA. We have some questions. I'll try to club it together. One of the questions is asking about how he can measure the lighting efficacy.
Lighting efficacy, normally you normally rely on not a measurement, basically. So basically, normally this is coming from the supplier. But let's say you can do the efficacy of the room, which is not really efficacy, but you can check how much lux are you getting in that particular room and how much wattage are you consuming for that particular room to come up with kind of an efficacy, but it's not really efficacy. Normally is for the bulb itself or the fixture itself. So normally this would be coming from the manufacturer, and you compare that to the other new, let's say, manufacturer. So bulb to bulb normally, but in general, you can basically check the lux level and how much wattage is being used in that room to come up kind of with the room efficacy.
Okay. Thank you. There are different types of questions regarding the simulation software, the modeling software. One of the questions says,
I can see them, yes.
Yeah.
So which energy modeling software do you recommend? So again, since this is an ASHRAE seminar, we normally don't name products. However, you can go to the DOE, Department of Energy in the US. They have a list of approved software to be used for projects for DOE or the federal government in the US. So there is a good amount of information there. I would recommend you to go on that website and check what are the modeling software that are available.
Okay. Another question is regarding the M&V. One of the questions is regarding how you, elaborate more on the measurement and verification. And is it really a useful tool to be used or not?
It is not just a useful tool, it's required to allow, again, for the M&V, I'm thinking maybe we can have another webinar on that. But M&V in general is basically trying to see how much have you saved. You cannot really measure the savings. You can only measure the new situation compared to the old situation and see how much you have saved. The issue with the M&V is that in a facility that is live and things are changing periodically, you might need to do some adjustments on the baseline. So let's say, as an example, an office building that had 0 data centers, and then next year, after the implementation, they added a big data center. Consumption increased. However, if you compare the baseline to the current situation where the consumption has increased, it's not because of the ESCO did not do a proper job, it's because there's data center that has been added. So then the ESCO or the energy auditor, whoever doing the M&V or the M&V auditor, will have to adjust the baseline saying, in 2018, let's say, if the data center was added, that would have been the baseline. And then they would compare to the new baseline. Again, we may have another session. I'll think about maybe having a different session with the guys at the Falcon chapter on M&V, because it's a very long topic that we can tackle on its own in an own presentation.
I think we might need it, Hassan, because of I think a lot of question is about M&V and how we can do it. Also, there are many questions about the energy baseline. So can you explain what is the energy baseline? How can we calculate it? And is it like reflected also in the ROI or no?
So the energy baseline is looking at, let's say, a specific year. So let's say 2018 or 2019 is my baseline year. So I would look at all the energy consumption that happened during that year. Normally, I would take that from utility bills, and that would be my baseline. And then my proposed case would be, when I am introducing these energy conservation measures, what would be the new consumption? So the baseline is 2019 consumption. The retrofit reporting period is the after I install the ECMs. Normally it should be lower. I want to reduce my consumption compared to the baseline. The baseline is when I did the analysis based on the data that I measured, based on the questions that I've asked, that would be the baseline. Also in the M&V session, if we do one, we're going to discuss this even more.
Another question from Asia is again about the baseline. It says Asia predominantly only cooling is used, the baseline figures from USA. Unfortunately, USA is mainly a heating, like, you know, it's heating more, especially in Chicago and other places. So their main question is about the hot and the humid countries, like, you know, Asia cities. Should they refer to a certain reference, or should they use their local?
Yeah, normally the more local data that you have, the better. So let's say in Dubai, we have some data on energy consumption or benchmark for buildings that we could use. I don't want to compare my building to a building in Alaska, but it doesn't make sense. However, even in the US climate, you can compare to maybe Miami or Florida area that have high humidity, or even Hawaii. That could give you a good indication, a good comparison that we used to use basically before we had data for the UAE. We used to go there and check that. But if you have local data, that's definitely much better. However, sometimes you just don't have that data and you have to use anything similar to the weather climate that you have.
Good. Very interesting question about EUIs. I mean, do we have or do we get any data for comparison or comparing the EUIs here in UAE?
Well, honestly, there's nothing that is publicly available at the moment. Because I've worked on projects with some governmental entities to do benchmarking, we do have that information, but it's not publicly available. There is some information from the Emirates Green Building Council that's available for schools, malls, and hotels. So this is publicly available. You can go to the EGBC website and download that for free.
Yeah. Another question, which is about ASHRAE guidelines. Is there certain ASHRAE guidelines that can be used for the financial analysis?
Again, the procedure for commercial building energy audits publication, that's very helpful. ASHRAE guideline 14 also have some of that information. So these two have good information on that. They also might refer you to other publications like from NIST and NIST standard 135, which is done for life cycle costing. That is also available for free from I think it was also from the Department of Energy in the US.
Yeah. Again, to the EUI, another question, how far we are from achieving and publishing an up-to-date building EUI benchmark for UAE market?
Again, I mean, we don't have anything from the government except for some reports. Like I mentioned, EGBC did some reports that are just, let's say, an initial step, because the sample is not large, but it's good enough, at least for the hotels. That was mainly based on Dubai data. So we have hotels, malls, and hotels, malls, and schools, basically from EGBC. Personally, because I've worked on a lot of projects, we have data, but unfortunately we cannot share it because these were mainly governmental projects. Until the government or some of the entities will share that, which will happen, I think, soon, because in Dubai there's the labeling scheme, and these things should be available by then. But I think it's going to take one more year for that. Again, it might be in a shorter time, but this is my own thinking or my own thoughts on that.
Some question about the certification. So one of the questions to Hassan is about how can I be a certified energy auditor? What is the first step to do this?
Well, again, which I recommend to go with the ASHRAE BAP. So if you go to the ASHRAE website, go to certification, select the BAP. There's something called the candidate handbook. Download that. It tells you exactly what needs to be done to qualify to sit for the exam and become a BAP. There are other certifications from other organizations as well that are available. But since this is an ASHRAE webinar, I'll focus on the ASHRAE one, which is the Building Energy Assessment Professional, BEAP. So download the candidate handbook from the website for that certification. It tells you exactly what needs to be done. And also there's a sample exam that you can buy from the ASHRAE website. I think it's for like $20 or $30. It gives around maybe 20 or 40 questions that will let you know if you are ready for the exam or not.
Okay. There is a good question here about can we replace conventional energy audit tools with artificial intelligence based tools?
I think that would be in the future. Yes, definitely. Again, the issue is that will you have an algorithm that will cover everything? That is the challenge here. I think in the future, yes. Right now, no. We still need to go to sites and check stuff. And again, not all buildings are very highly digitalized. Let's say you go into a BMS, you rarely find a BMS that's functioning properly. All sensors are reading correctly. So you wouldn't really rely on a lot of data from site unless you make sure that they are correct. So I still think it's going to be some time before we do that. But yes, definitely that would be in the future.
Okay, there is also some question about bases or resources do you use to find out discount rate and energy unit prices increase in financial calculations?
So normally, depending on where you are, what is the discount rate? So it really depends on where you are, basically. So whatever you are in what area, you check what are the normal discount rate.
Yeah, yeah. By the end, I think there are a lot of questions, Hassan. I mean, it's hundreds of questions. So I think most of the question, which we cannot answer it now on the live mode, I believe Mr. Hassan Younes is going to answer them individually. And I think we will send all of the answers and the responses of all of the questions to all the participants of the webinar. Hassan, before I close the webinar, you want to say anything or?
No, thank you, everyone. Thanks, Abdullah. Thanks, ASHRAE Falcon Chapter members for making this happen. And thanks, everyone, for taking time. I know a lot of you are fasting, and I wish you a blessed month. And hopefully this tough time of COVID-19 will pass soon, and life will go back to normal.
Thank you, Hassan, so much. I really, really appreciate your participation and Griven consultant participation. It's our pleasure that you are one of our speaker and guest of honors for the ASHRAE Falcon chapter. One of the things which I would like to share with all of the participants to our webinar that we are actually introducing a series of webinars by the Falcon chapter. And two of them are going to be happening this week. One of them is by Monday, and the speaker will be Mr. George Berbari of DCPRO. The webinar is going to talk more about the healthcare facility designs and like, you know, the new technologies that's implemented in hospitals and the healthcare. The timing gonna be by Monday 1 p.m. UAE time, and the link for the webinar gonna be distributed as usual to all the ASHRAE members. We have another webinar by Wednesday 1 p.m. UAE time. It's going to be done by or presented by Mr. Saeed Laham of Train. And again, it's going to be more into energy efficiency, but in this time, it's gonna be energy efficiency in air-cooled screw chillers. So for the like, you know, it's more into the HVAC equipment side. Again, thank you, Hassan, so much for participating today, and thanks for the valuable presentation of the energy management. We really appreciate, and we will be very thankful if you can also prepare another one for the baseline and measurement and verification. I can see a lot of people are interested for such topics. especially nowadays. And thank you all. As Hassan mentioned, Ramadan Kareem to all, and wish you all the best. Thank you.
Thank you.